Hi, I'm Chris. We're taking a further look at polar and rectangular equations, and here we have r equals 3 over the quantity of 2 minus cosine theta. So in order to convert this into rectangular form, what we want to do is get rid of our denominator. Denominators in general are a little bit messy, so we're going to multiply both sides by 2 minus cosine theta to get rid of that denominator, clear the denominator if you will. So we'll have r times 2 minus cosine theta equals 3. And we can distribute that r to each term. So we'll have 2r minus r cosine theta equals 3. And then just like what we saw in the last example, which hopefully you watched, if not, feel free to click here and take a look. But what we want to do is try to get the r by itself. And in this case, to do so, we're going to move r cosine theta to the other side. So we'll have 2r equals r cosine theta plus 3. Now, what we can do here is simplify this side quite a bit. If we have r cosine theta, hopefully, if we're dealing with rectangular and polar conversions, we know that x is equal to r cosine theta and y is equal to r sine theta. So we're going to substitute in an x in place of r cosine theta, and we're left with 2r equals x plus 3. But we've still got this extra r over here, so we're not done yet. What we need to do is remember that our other piece of information that we have in order to substitute is r squared equals x squared plus y squared. So if we do that here to get r squared so that we could substitute in an x squared and y squared term, we're going to square both sides. And when we square both sides, let's see what we end up with. So this would be 4r squared. And then when you square this side, just please make sure that you remember to FOIL it. A lot of students do the difficult part of getting to this stage in the problem. And then rather than foiling, they just put x squared plus 9. We have to make sure that we're careful and that we FOIL this. So when you square both sides, it's the quantity squared. And when you FOIL that, you're going to get x squared plus 6x plus 9. And then from there, we can substitute in x squared plus y squared in place of r. And we'll have 4 times x squared plus y squared equals x squared plus 6x plus 9. From there, we can distribute the 4, and depending on what you're asked to do or how much you have to simplify for the problem, we can rearrange this accordingly. So I'll show a few steps of that. But here, it's just the simplification process that we're now going through. So we'd have x squared plus 6x plus 9. And if we were to try to find a combining like terms on this and try to find an expression by bringing all of our values to the other side and using completing the square, then we would subtract the x squared. We'd have 3x squared minus 6x plus 4y squared equals 9. And then from there, we would try to factor out a 3 and factor out a 4 and complete the square on each term. And for that, completing the square is actually addressed in another one of our videos for being able to find the equations for ellipses and hyperbolas, which is something that you see towards the tail end of Algebra 2 and a little bit more in depth in pre-calc. So here, by the time we got to polar, hopefully we're comfortable with that. If not, click here and take a look at those other videos, and I'm going to work through this part relatively quickly. So if we factor out a 3, we'll have x squared minus 3x. Leave some room to complete the square, and this would be 4 times y squared on that. And then this will be equal to 9. And what I want to show in here is that when we complete the square, you take half of this term and square it. So that would be 3 halves squared, which would be 9 over 4. And whatever you add to one side, you have to add to the other. This term we're not adding or subtracting anything to, so we can leave it as is. So we would have 3 times x squared minus 3 halves. When you factor it, it's x minus 3 halves quantity squared, and then plus 4y squared equals, and when you add those together, that's 36 over 4 plus 9 will be 45 over 4. And then from there, if you wanted to multiply by the reciprocal, or divide throughout by this term. You could do that on this side to set it equal to 1. You could also pull this over to the other side. But for now, this form is the kind of form you would see a question like this written out in for one of these problems in dealing with polar to rectangular conversions for r equals 3 over 2 minus cosine theta. For more, please feel free to check out our other videos, and thanks for watching.